In this video, we're asked to find the absolute maximum and minimum of the function p of t equals sine of t plus cosine t on the closed interval from negative pi over 2 to pi over 2. Now, because this function is continuous on this interval and we have a closed bounded interval, we have what's called a case called the extreme value theorem, which means we need to just evaluate our original function at its endpoints and any critical points, and then we can identify the absolute max and absolute min. We're guaranteed to have each. So first thing we do is we find the derivative. So p prime of t, derivative of sine is cosine of t. Derivative of cosine is negative sine of t. And then our next step is take our derivative and set it equal to 0. Now this is going to be where cosine of t is equal to sine of t. And there's a couple places where that happens. So if we think of our unit circle, sine and cosine are the exact same here at 45 degrees or a pi over 4 angle. Then the other place where they're the same is down here in the third quadrant because they're both negative. Now that would be at, if we go this way, it would be at 3 pi over 4. If we go, or excuse me, it would be at 5 pi over 4. That's not in our interval. If we come around this way, it would be at negative 5 pi over 4. Or excuse me, negative 3 pi over 4. Got those backwards. Again, not in our interval. We're only looking from negative pi over 2 to pi over 2. So this is a critical point of our function, but does not fall in our interval, so we do not need to worry about that. So we only have 3 places we need to worry about: negative pi over 2, and pi over 4. And what we're going to do is we're going to evaluate our function at all of those. So p of negative pi over 2 gives us sine of negative pi over 2 plus cosine of negative pi over 2. Sine at negative pi over 2 is equal to negative 1. Cosine is equal to 0, so that equals negative 1. Now we'll do our function at the other endpoint, p of pi over 2. So now we have sine of pi over 2 plus cosine of pi over 2. And now we have 1, because now we're up here at the top, plus 0 equals 1. Last thing we have to check is the only critical point that was in our interval, p of pi over 4. So that gives us sine of pi over 4 plus cosine of pi over 4. Again, we know these are the same values because that's how we found the critical point. Rad 2 over 2, and cosine is also rad 2 over 2, which gives us 2 square root of 2 over 2. Those will cancel, and we get square root of 2, which is greater than 1. So this is our absolute max, and it occurs, or its location is at pi over 4. So the absolute max is rad 2, and where it happens is at pi over 4. Our absolute min is right here at negative 1. So the absolute min is negative 1. That's the absolute minimum value. Where is its location, or where does it occur? At negative pi over 2.